Hey everyone, so with today's guided practice, I wanted to go ahead and do a couple of these IXL problems with you, mostly so that, well, for two reasons. First of all, I want you guys to see just how you should input these, what you need input in order to get the answer, but then I also want to go through and kind of review with you, just like we did, if hopefully you watched that review video that was posted above, we can look at how we can use what we see as far as our input term and our output term. We can use both of those things in order to help us figure out what we need to do in creating a function rule. So each of these is going to be set up as a story problem. So let's go ahead and read through that, and then we'll check out our function table. So it says Becky works at a grocery store. Every day she spends 2 hours stocking shelves and the rest of her workday bagging groceries. Let W represent the number of hours Becky works in a day, and C represent the number of hours she spends bagging groceries. And then we need to complete the equation that represents the relationship or the rule between W and C. So that relationship between W and C, the relationship between the input and the output, that's our function rule. So that's what we're looking to create. So first of all, let's look at our inputs. What we're going to put into our equation will be our W values, and what our C values, that's going to represent our output. That's going to be kind of our answer once we plug the input into the function rule. We should get this number as the output. So in this case, let's see. So it says C represents the number of hours she spends bagging groceries. So the number of bagging groceries is over here, and let's see what happens with our outputs. Let's see. This looks like they're getting larger by 1. Okay, there's plus 1, plus 1, plus 1. So plus 1 works for this side. So for our C side, it looks like our outputs are actually just getting larger by 1 each time. But our inputs look a little bit different. Now this looks a little bit strange. Well, no, 4 to 5 is 1, 5 to 6 is 1, and 6 to 7 is plus 1. So these are all just getting larger by 1. So it looks like for our input and our output, it looks like it's a 1-to-1 ratio, which means if 1 is changing by 1, now let's look at the 2, but let's look at our correlation between the two things. This means we're probably not going to be multiplying anything since it's a 1-to-1 ratio. We're just going to put something in and then get something out by doing something in between these two things. Now we just need to look at our correlation from column 1 to column 2. So between our W, our input, to get to our output, that's 2 less. 5 to 3 is 2 less. 6 minus 2 is 4. 7 minus 2 is 5. So for each of these, our rule looks like we're going to take our W term and we're going to take 2 away, and that's going to give us our C term. So basically I just need to take this and plug it in over here. So it looks like because our C is over on this side, we're just going to still do W minus 2. And there you go. That's all you need to do to solve these problems. We'll go ahead and hit submit. See if we were correct. We are. We can go ahead and try the next one together. So hopefully that was good. I would like you to go ahead and close this video out. Check the next problem. Try it before you hit that video tab, and we'll see how you do.